Welcome back, everyone, to another Containers from the Couch. And this is one that I'm particularly excited about because I've actually struggled with autoscaling in the past. And, you know, autoscaling, we're going to talk about autoscaling your ECS service. And most of the examples that you find are always going to be based on some very simple metric like CPU utilization or memory utilization. And so a while back, I did a blog about autoscaling based on transactions per second through a load balancer. And that was great, but it only applies when you're using a load balancer. So we have VG here with us today, and he's going to talk to us about autoscaling based on custom metrics that you might be collecting using Prometheus. So we're going to look at scaling based on a Kafka topic. And I'm going to let him take it from here and walk us through the whole thing. But VG, why don't you introduce yourself again?
Yeah, sure. Good afternoon, everyone. My name is Vijay Sarathi. This is actually the second time I'm on the couch. The last time that I was here, there were 6 other people, and we were jostling for position around the thing. So I am a senior container specialist SA at AWS. I've been at AWS since September of 2019, and I worked in the role of a generalist SA, as we call them, for about a year, and recently I transitioned to the role of a container specialist. The topic of containers, ECS, EKS, has been pretty close to my heart for quite some time. I've worked with them for a few years, even before coming to AWS, and I've continued to stay very strongly engaged in that area, contributing to blog posts and other ways of showing some thought leadership. So today, as Brent mentioned, I'm going to delve into the details of how we are going to do autoscaling an Amazon ECS service based on custom metrics. Now, Brent, is it? Can I continue? There's no more introductions, right? Or
yeah,
okay. Yeah.
Let me go ahead and pop your screen up, and
okay.
Then we can go on from here. So now your screen is up.
Okay, great. Just a very quick background and what I'm going to demonstrate today. The work is largely based on a blog that I recently wrote in the containers blog at AWS, which is shown here. And I will kind of quickly walk you through the application architecture before we actually delve into the details about metrics collection and autoscaling. The use case that I picked here, it is something which is quite common these days, and it's something that I used in my previous job also in a production setting, is that you have messages that are streaming in from various different sources, and over here on the left-hand side, it comes in through the load balancer, and these messages are actually received by, we are using Kafka topic as Kafka as a PubSub broker here. And there is a producer service which is receiving these messages and publishing them to a Kafka topic. And then on the downstream end, you have a set of one or more consumers that are pulling messages from this Kafka topic, and then they are actually performing further downstream processing. Usually the way things work in the scenario is the producers are just kind of drinking from a fire hose and then sending it to the Kafka topic, and of course the consumers also have to drink from the fire hose, but then oftentimes they have to do a little bit of some downstream processing of these messages. So oftentimes that the rate at which the messages are processed by the consumer, it lags behind the rate at which the messages are produced by the producers. So the whole the strategy here is to the way the application of scaling comes in is to scale out the number of tasks of the consumer service so that all of these tasks in the consumer collectively can stay abreast of the rate at which the messages are produced over at the producer end. So that is the overall strategy. Now, what I have shown here in this application architecture, there are also other components. I show CloudWatch, I show AWS Lambda, then Amazon application Autoscaling, as well as another service called CloudWatch Agent for Prometheus service. And we will we'll talk more specifically in detail about each one of these things and what role they play in scaling the consumer service. Okay.
While you have this up on the screen, I just want to sort of reset for a second, because I think the bottom half of what you're showing here is super common. It's so normal these days to see an event-driven architecture going through a message broker like Kafka. So having, n number of producers putting messages on the bus and then n number of consumers pulling them off allows you to decouple the work so that you can decide how fast you want to process versus how many workers you want to maybe pay for or be responsible for. So this is a really, really, really common pattern, but figuring out how to auto scale it is something that people are still, they're trying to figure out because you can't simply do it based on,
any of the predefined metrics which are available
exactly
by ECS. Yeah.
Exactly. All right. So go on. I'm sorry to interrupt.
No. Very, very good point. So okay, so we covered the application architecture, and let us quickly. I'll show you what the footprint is on my. And I already have an ECS cluster provisioned in a VPC with some subnets and all that. So, let's assume that, let's take it for granted that all those infrastructure pieces are humming along fine. And we will just look at the footprint of the services that have been deployed to the cluster, right? So I have the consumer service, which is using a particular task definition, and I have one instance, one task running in the consumer service, and then the publisher service, and I have two. And the reason why I have two is because in my particular setup, the VPC actually has got two private subnets, and my Kafka cluster actually has got two brokers, one in each subnet. So basically, when you create a publisher service with two tasks, there is one task is actually there is one task per broker, and that is the reason why I have two tasks on the publisher service. I also have deployed the CloudWatch agent for Prometheus, which is running only one task. But we will come to that very shortly later in the presentation. What I wanted to show you is kind of scroll up and show the makeup of the Kafka cluster, or the Kafka topic. The topic is called Octank, which is a popular name that is used internally at AWS. And this topic has got 10 partitions, 0 through 9. For those of you who may not be very familiar with Kafka, the Kafka PubSub model works slightly differently from a PubSub model such as SQS. Is that when you actually, consumers can actually pull messages from a Kafka topic as a consumer group, right? So so in this case, the maximum scalar that you can actually get is like every time when a consumer is pulling messages from a Kafka topic, it is assigned one or more partitions. So right now, because I only have like one task, this one task of the consumer service is pulling messages from all 10 partitions in that Kafka topic. But then as the scale out happens, the maximum scale out that you can get is up to 10, right? Because if you spin up any more than 10 tasks, those additional tasks are not going to have any partitions to pull messages from. So in this particular case, so that is the maximum scale out that you can get.
I always think of it like musical chairs, where the consumers come up, and if they don't have a place to sit, then they're out, which causes a lot of churn because every time a new consumer is added, it has to coordinate with all the other consumers to decide who gets to pull off of which partition. So there's this rebalance effect.
Exactly, the consumer rebalance, and these are all very well defined API. I mean, the application that I've written, and it's written in Java, and it uses the Kafka consumer and producer APIs for Java, and it makes it very easy to actually handle all this consumer rebalancing that happens, when additional tasks come and go into the service. And of course, one more thing that I want to point out is, anytime when you're actually dealing with these kinds of applications in a real production environment, this is one of the things that you actually want to pay attention to. So you don't want to actually set up your Kafka topic, for the kind of load that you can handle today. You want to think about future growth, because 6 months later, you say, hey, these 10 partitions are taking way too many messages, and I need to have more than 10 consumers. Well, you're going to have to completely repartition your topic. So oftentimes, you want to think ahead, and even if you really don't need it, partition your topic into a topic into 50 partitions, so that you have that horizontal scalability available when you need it. Okay, so enough said about Kafka. So we will go back to what we were talking about, which is application autoscaling. And as Brent mentioned here, what we are trying to do is do the scaling based on a custom metric, right? So I'm going to quickly switch to some Java code here. So the custom metric that I have, so both in the producer service and in the consumer service, I have instrumented them with the API, the applications, to track the number of messages that are getting produced at the producer end and the number of messages that are getting consumed at the consumer end. So that is what this messages produced total and the messages consumed total, that is the metric that I'm tracking in this application. And the interesting thing about ECS is there are actually two different ways in which you can actually collect a metric and then report it to CloudWatch. The first approach is actually shown here, where I'm calling this function called put metric data, right? Well, before that, I have this helper methods called increment messages consumed, and right. Wherever, elsewhere in my code, whenever, and I'm pulling a message from the Kafka partition and then processing it, I'm just simply going to call this inc messages consumed so that the number of messages is incremented. So it is, the messages consumed here is simply just a monotone increasing counter, right? Nice. And then what I can do is, using a simple timer, I can periodically call this function called put metric data, let's say once every 30 seconds, it'll basically publish all the accumulated information. And what I'm doing here is I'm using the CloudWatch, the CloudWatch SDK, and which has an API call called put metric data. And I'm publishing this particular metric into a CloudWatch namespace. And you can publish it into any CloudWatch namespace that doesn't start with AWS. So the namespace that I've chosen is called ECS/CloudWatch/custom. And then I'm also giving it a couple of dimensions like task group and cluster name, which are basically the name of the ECS cluster and the task definition that this particular service belongs to. So with all this
looks really
information,
easy. By the way, this is a good example to follow because this is really simple simple to look at and read, and it really does effectively show what you're doing. All you're doing is incrementing a counter, and then you're publishing it periodically.
Right. Yeah, and you don't even the rest of the code could be too ugly to even look at, but we don't really care, right? Suffice it to say that we just call this from a couple of wherever you consume a message, and then there are 100 different ways in which you can make a timer go off in any program written in modern programming languages, and then you call this put metric data API periodically and push these custom metric into CloudWatch. So that is how you publish a custom metric. Before the dawn of Prometheus, before when all that you had was the CloudWatch. Yeah. Now, when you have Prometheus, okay. So what I have done is, I actually want to show side by side in the exact same deployment how you can track the same metric and report it using two different ways.
Awesome.
So I actually I'm using the Prometheus client library, and this is which actually provides a class called counter, which is again just a simple monotone increasing value. And I'm kind of using Prometheus client library, the APIs to initialize that counter, with some labels, just like you have namespaces in CloudWatch, the equivalent, the nomenclature in Prometheus is labels for every metric. And here again, I'm doing the same simple thing, and I have a helper message called increment message consumed and increment message published, which simply increments these two counters. By the way, I've called them message produced total, but then they are actually different when they are reported to CloudWatch, because they actually get reported to two different CloudWatch namespaces, as we shall soon see. Cool. Now, one thing that is interesting is, whereas in the CloudWatch case, you actually saw code that was actually pushing the data, metric data, into CloudWatch using put metric data API, but then we don't have any of that in Prometheus, right? And that is because when you're deploying, in the case of Prometheus, there is a Prometheus server that is often deployed in the cluster that will scrape all the metrics from your services and then report it to the final destination.
I was going to say,
we don't have,
with CloudWatch, the style is to push the metric to CloudWatch, but
yes,
Prometheus, the more common pattern is to actually just store those metrics and make them available, and then have a scraper come along and scrape periodically.
Exactly.
And over time, I don't know what the best answer is, but over time, we see a lot of people using the Prometheus style of doing things simply because it seems to be a little bit more scalable. You can reach out, and if you get bogged down, then you get bogged down. But in the meantime, the service itself is only caring about making the numbers available, not publishing them somewhere. I've seen in my past, I've seen a whole website crash simply because we couldn't push metric data out to the destination where it needed to go, and so it started buffering and eventually filled the local buffers and started making things crash. Well, that'll never happen with Prometheus, because it'll just sit there and write and overwrite and overwrite constantly. And if the scraper has a problem, of course you troubleshoot it and fix it, but it'll just come along and scrape the metrics as needed.
Right. Now, the other thing to point out also is, in the push model, all the data is sort of trapped in your application, and it is exposed only when you actually call invoke a certain API to push it to some final destination. But then if the destination that you want to push the metrics changes, then it potentially requires new code to be written, or perhaps
Right.
if instead of CloudWatch, if it is something else, you have to change your code. Whereas in the pull model, you just simply make these metrics available at the /metrics endpoint, right? So you could either what we are doing now is we are actually going to install the CloudWatch Container Insights agent for Prometheus, which because we don't yet have a Prometheus server that actually runs and does discovery in ECS. So this Container Insights agent is essentially a stand-in for the Prometheus Prometheus server. We'll talk a little bit more about that momentarily. But you could also, so that agent is actually gathering, collecting these metrics from this endpoint, pulling them, and then it is sending them to CloudWatch. Now, you could very easily envision that it could be sent to some other destination, and you could use any other type of OSS-based monitoring tools, that are open telemetry-based that recognize
have a second
Prometheus
scraper and a third scraper sending to a second destination and a third destination. However you want, it's decoupled. It's awesome.
There are many scrapers that are available that are Prometheus compatible that you could use to send your metrics to different destinations. But of course, the big question here is, collecting metrics is one thing, but then ultimately, what is it that you want to actually do with those metrics? What type of what can you do with the metrics? Some type of actionable intelligence is needed, right? So that's a completely different topic. So now the CloudWatch Container Agent, let's talk a little bit more about it, right? And I mentioned that this is essentially a stand-in for the Prometheus server, right? Now, one of the nice things about Prometheus is that it has a very solid service discovery capability. That it's able to automatically detect the services that are available in the cluster. I mean, Prometheus is commonly deployed in the Kubernetes world, and there are service discovery mechanisms that are built into Kubernetes that enables this to be done very easily. However, on ECS side, we don't have any built-in service discovery mechanism. So what the CloudWatch agent requires is, it requires you to provide a set of static configurations, which is like, what I have shown here. And this static configuration, and this is actually very well documented. I mean, the stuff that I have done is all exhaustively documented in CloudWatch Container Insights documentation on our web, on the official documentation. So going back to what I was showing you the code, or lost train of thought. Oh, here. No, I think I was showing you the system parameters. So sorry. So I am explicitly saying, hey, scrape the metrics, from Kafka consumer task and Kafka publisher task. I'm telling it, and those are the only two services that I've deployed here. But in a big cluster with 20 other services, you can envision that this would actually be many other services. And then there is also this thing called embedded metric format that CloudWatch uses, and that is actually a way that is used in CloudWatch to actually gather these metrics and send them to CloudWatch as simply log events. And instead of explaining this, I'll actually show you how that actually works. And I had a tab with the logs, which magically, here, right here. So this tab that I'm looking at, so the Container Insights for Prometheus is going to send all these logs to this very particular log group called ECS Container Insights /name of the cluster /Prometheus. And then when you click one of these logs, you will see that it has a whole bunch of data. It has actually the message consumed total, which is the metric that we are scraping. It has its value, and it has several other key value pairs. And what is also included is this JSON fragment that we called as the embedded metric format data. So here, it actually says, hey, given all this data here, you identify messages consumed total, this as a metric, and then associate the key values cluster name and task group, and these two as dimensions, and then put them into this namespace called ECS Container Insights Prometheus. And this is how the CloudWatch agent for Prometheus is able to extract the metrics that are exposed by your application, send them as log events, and then ultimately extract metrics out of it. So that's all the explanation about how we have deployed the producer and the consumer service, and how we have instrumented them to push metrics to CloudWatch using CloudWatch SDK, and to have the agent pull metrics that are exposed using Prometheus and the client libraries, and then have them manifested as CloudWatch metrics using EMF. Okay,
Awesome.
now let us switch gears and come to the the metrics, looking at these metrics and getting into the auto-scaling part. So what I have shown here, so here I have a whole lot of metrics that I've plotted here, and let me just hide all of them and then turn them on one by one. It will cooperate. Okay, so we got a clean slate. So okay. So this metric that is called M1, that is, if I hover on it, this is the sum of the messages that is produced in a trailing 1 minute period. And then this is the sum of the messages that is consumed in a trailing 1 minute period. And then I have CW to indicate that is the metric that we pushed, using the CloudWatch SDK. Similarly, I also have the same type of metric, with the prom, the term in there, and this is the same kind of messages produced and consumed that is done using Prometheus. Now, if I just click on this sum, that particular metric alone, it is probably, you may not even see it, because it is completely going outside the scale of what I have specified here, because the number of messages itself, when you're tracking a particular metric as a counter, the actual raw value itself is really not very meaningful, right? Because it is a monotone increasing value. It'll be 100 at this instance, and then 1 hour later it'll be 1 million, right? So you really can't do any kind of meaningful auto scaling with that. So what you really need to do is compute some kind of a utilization metric or a rate metric, right? Which sort of increases proportionally based on the number of tasks that you have, right? So what I have done is here, the blue line here, this is the number of messages, the rate at which the messages are produced in the trailing 1 minute period. Okay? And this is the rate at which the messages are consumed in the trailing 1 minute period. Okay. So if I hover on it, we can see that the producers are pumping messages into the Kafka topic, those 10 partitions at about 100 messages per second. But then the hapless consumer, which is consuming all 10 partitions, is only able to have a maximum throughput of processing about 20 messages per second. And just to convince you that the metrics that are pulled using the Prometheus model are also reporting the same values. When I turn those checkboxes on, and you will see that they all kind of go right on top of each other. So which basically means that I'm reporting the metrics exactly the same way, both using CloudWatch SDKs and as well as using Prometheus. So nice. Just wanted to show that, just to convince you that I'm not cheating.
Yeah, that's great to see, because there would be some subtle deviation, because the push model would have timing one way, the scrape model would be timed slightly differently, but clearly they track right alongside each other. Right.
Okay. So now, we have we are reporting, we are having these metrics reported in CloudWatch. So what is it that we want to do now? What is our goal? Now, our consumer is really lagging behind the producer, right, by a factor of almost 5, right? And this guy is at the most able to consume 20 messages per second. So we want to perform a scale out in such a way that the number of consumer tasks is increased to the point that the combined rate of messages processed by all of these consumer tasks tracks as closely as possible to the rate at which the messages are produced, right? And that is the problem that we are going to solve. Now, so now is where when we want to talk about application autoscaling, right? So
Right.
ECS has built-in service autoscaling capability, and that autoscaling capability is provided by another managed service called application autoscaling. And what you can do with an application autoscaling, as Brent mentioned at the top of the conversation, it is very commonly used in conjunction with certain predefined metrics, right? For example, ECS itself, for given a certain number of tasks in a cluster, it'll report metrics such as the CPU utilization and memory, the amount of memory utilization by those tasks. All these metrics are automatically reported by ECS into CloudWatch. So what you can do is you can very easily set up metrics and metric alarms in CloudWatch using what are called target tracking policies that allows application autoscaling to scale out or scale in the number of tasks in your ECS service based on these predefined metrics, right? But then we are not actually dealing with predefined metrics here, right? We are actually dealing with custom metrics, right? Now, application autoscaling does in fact provide a mechanism to scale out, to scale based on a custom metric, right? However, one of the requirements there is that this custom metric is something that has to be pre-computed and complete and readily available in CloudWatch as a persistent metric. And what I mean by that is, when in this graph, what I'm showing is the number of rate of messages produced and the rate of messages consumed, right? These are not actually the real CloudWatch metric, right? The actual CloudWatch metric is this the messages produced total, right? For example, when I go back to this, these are the CloudWatch namespaces into which we push the metrics, right? Remember that we said that we were sending the metrics based on CloudWatch SDK to this namespace called ECS CloudWatch Custom, which has got two metrics, namely messages produced total and messages consumed total. I'll come to this third one momentarily. And then the ones that were produced by Prometheus were in this other namespace, and these are the actual metrics. However, in the graph, we are plotting the rate, but then that rate is actually computed on the fly using metric math expressions that CloudWatch supports. Okay.
Yeah. So let's just try and clarify real quick what you said. What you said is perfect, but the metric itself isn't the rate right here. We're actually taking the metric, applying some computation to it, and then graphing the result.
Exactly.
And because of that, we can't autoscale based on the result of that math. Right. So what do we do? How do we fix that?
So the way to fix that is kind of have a mechanism to compute this rate and have that reported back into CloudWatch as an actual metric, right? Yeah. So that is not something, we don't have anything out of the box available in CloudWatch or anything to do that. And this is where you put on a little bit of elbow grease and then you write some code in your favorite programming language and you can make anything work, right? So what I have done is, this is a very simple lambda function, or this is a very simple program that I've written in Go, which is deployed as a lambda function. But I will explain what this does is, and this is what this Go program does is, it uses basically, if I look at the top, it just uses the AWS SDK for CloudWatch, AWS SDK for system parameter store in ECS. It first gets the number of tasks which are running under the target service. And the target service in this case is the consumer service, right? Which is initially running one task, okay? And then I have actually just, what I have done is, I have used an SSM parameter to actually help it compute the derived metric. And let me very quickly show you what that is. If you bear with me, I should have had, yeah, this particular file. Okay, so this is a JSON file, which you can use with CloudWatch APIs. Like, here I'm having, this is the metric that we are producing. For example, messages produced total, right? And this belongs to this particular namespace, and I'm specifying the dimensions that are associated with this particular metric, right?
Right.
And what I'm doing is I'm first using metric math expressions. I'm computing the sum of this counter over the last 66 seconds. And then, I'm calling it by that name, and I'm calling that metric by the name M1. And then I'm taking M1, computing M2 as M1 divided by 60. That gives me the rate of messages produced over 1 minute. Now, this is what we were actually graphing in the metrics dashboard. But what the Go function does is it actually uses this configuration data, and then it basically reads that, and then it uses further down here, it actually retrieves the metric data for the last 5 minutes from CloudWatch, okay? And then it'll basically use these math expressions that are provided in this configuration, thereby compute this metric called rate messages produced, and then push it back into CloudWatch as a metric, okay? And that is what we have done. When I go into the Lambda dashboard, and I will see this Go program is deployed as a Lambda function called CloudWatch metric adapter. And again, this guy is triggered to run once every minute. Okay, and depending on the resolution that you want for these metrics, you can make it run at a more frequent rate. But in this case, for this demonstration purpose, 1 minute would suffice. So when I do this, yeah.
So you're running it once a minute, but it's pulling 5 minutes of data and calculating the rate minutely over the last 5 minutes. Is that right?
Right. That is correct. But there is a little bit of an overlap, right? So for example, when it goes up at 12 a.m., it is going to pull all the way, because the resolution with which I'm pushing the data into CloudWatch is that 1 minute intervals, right? So it's going to get all the data from 11:55 at the top of every minute up to 12 p.m. And then it is going to compute a metric based on that. And then when it goes up again at 12:01, it is going to pull from 11:56 to 12:01. So it may potentially recompute some of those metrics, but then when you're pushing it back into CloudWatch, as long as you're pushing them back with the exact same timestamp, the number of metrics that you're reporting remains exactly the same. There's really not a lot of penalty that you pay for this additional compute, as long as the number of metrics that you're pushing is not any different. But that's a good point, and it's you're paying a lot of attention. Good. Asking the question. I'm kidding. Okay, so our Lambda function, its job is to compute this rate metric, and that is what you saw that I momentarily wanted to hide away from you. Is this first of all, when I go back to this all metrics and then go into this namespace called ECS CloudWatch custom, third metric that showed up, rate messages produced. Now this is a real metric in CloudWatch, which I can now use to perform autoscaling on. And when I go back to my panel, and when I click on this graph, right, or when I graph it, and you will see that it's overlaid right on top of this blue line, and that's because at the rate of messages produced, right, divided by the number of consumer tasks, is basically because we have only one consumer task. Essentially, it turns out to be the same. Okay, so now let us come to how do we actually do the application autoscaling? And the way to do that is first you have to create this configuration file. And this is a configuration, and I mentioned earlier about how application autoscaling also supports custom metrics for performing its scaling, and this is how you actually provide a custom metric definition. In this case, I'm telling application autoscaling that it has to perform its scaling based on this custom metric called rate messages produced average 1 minute in this particular namespace, and these are all the CloudWatch dimensions and so forth and so on. And the important value that I want to look at is this target value of 20. So what I'm telling application autoscaling is perform the scaling in such a way that this metrics stays at or below this target value of 20. Okay, and what it is going, and this is where it is very important to actually have what is called as a utilization metric, that increases proportionally or increases or decreases proportionally to the number of tasks in the target service. Because so what application autoscaling will do is it'll initially look at this value of rate messages produced average. When we go back to this graph, it is close to 100 because there is only one task, right?
Yeah.
And then we are telling it, hey, make it so that this is no more than 20. So it is going to do a simple calculation and say, aha, so if I spin up 5 additional tasks, then 100 divided by 5 gets close to 20. So when we deploy this autoscaling, we will expect application autoscaling to spin up to 5 additional tasks, and thereby there will be 5 more consumers pulling messages from the Kafka topic. And if all of them are processing messages at the rate of 20 messages per second, we start tracking we start being abreast of the rate at which the messages are produced. And I hope that, yeah.
Yeah, so let's talk about this just from the extremes also, because right now we're at one extreme where we have roughly 100 messages a second coming in, roughly 20 being processed. We're never going to catch up, right? Like this is a terrible scenario. We could, we have 10 topics that we can balance across. So one way to handle this might be scale the jobs up to 10 and have 10 consumers. But and that would certainly catch us up and keep us up. But it would also mean that we have a lot of wasted compute, right? We don't need 10. And so the sort of holy grail is have just enough compute to keep up.
Yeah.
And so that's what you've built here. That's what you're working through is analyze how many, we go into this knowing a consumer can process 20 and we know how many we're receiving. So we now have enough information to do the math to know how many consumers we need.
Exactly.
And we can track that.
Yeah. Because I've had, when I talk to some customers, they ask, when they talk about autoscaling, and they ask us, okay, how do I specify these thresholds and all that? There is really no magical formula or anything like that. You got to know your applications well, right?
Yeah.
So the right way to do that is, whatever is the service that you're trying to scale, right? You want to know what is the maximum throughput that it can handle with one task, right? In this case, we basically did one task, and it's doing whatever processing that it's normally doing, right? And it's trying to drink from a fire hose, and the most that it can do is 20. So we know, okay, 20 messages per second, it is going to max out. And therefore, we can kind of use that as the basis for our autoscaling. If you want, if you wanted to, if you want them to be less taxed, you can actually set the target value here as 10. But let's keep it as 20. And then to actually perform the scaling, the first command that I have to do is run this command, which says, take the desired count, which is of the tasks of the consumer service, and set it as a registered scalable target. And you can see that I'm setting the min capacity to 1 and max capacity to 10. And the reason for that, again, is the maximum that I can meaningfully scale out to is 10 because there is only 10 partitions in my Kafka topic. So let's go ahead and run this command.
We're down to about 10 minutes left, by the way.
Yeah, hopefully we should be able to see the scale out happen in 10 minutes, if this all works.
Yeah. Okay,
so we ran this command, and it worked. And the next thing is create a target tracking policy. And now this is where you're telling application autoscaling to use this configuration and set up some target tracking policies. And we will see. Let that run and see what happens next.
And while this is running, the important bit in that file, and you, by the way, if you're in the audience, you'll see all of this in the blog post. But the important bit in this file is that the target value of 20. That's how we know we're going to be on target if we're hitting our target value of 20.
Right. When we did this thing, and based on the output that you see, that application auto scaling, based on the information that you provided, it automatically manages a set of CloudWatch alarms, right? And let's go to the CloudWatch alarm dashboard and see what these are. And you get two alarms. One is a high alarm, right? And the other one is a low alarm. So this alarm high, let's take a look at that, right? And this is this basically says, right, that if I scroll down, that if the target value is exceeded, this is how CloudWatch does it. And it basically, you know, 1 minute period, you know, if it has exceeded that threshold for three periods, for 3 times in the last 3 minutes, then the scaler, and that's what this one says. And you will see that it also sets up a low alarm, which is a little bit, which is a lot more conservative. Here it says, okay, if the target value goes below the threshold for 15 out of 15, 15 out of 15. In other words, application auto scaling, it tries to make sure that your service is highly available, right? I mean, you know, things basically you know, go to hell in a handbasket, you know, when the messages are coming at a very fast rate and you don't have enough tasks, right? So you want to perform the scale out very in an agile manner. But then you want to be a little bit more conservative on the scale down, and that's why it makes sure that you don't have any kind of you know, noisy load that makes it seem like the load is going below the threshold, and that's why it waits for like 15 minutes before the scale down happens. So anyway,
exactly. Because given a choice, we would much rather be able to handle the spike versus waste a little, you know, being above our compute needs. So if we have some excess capacity, that's still preferred over not having enough capacity. So that's what these thresholds reflect.
Right. So now, when we first created these alarms, and if you had paid attention to the dashboard, and it said insufficient data initially. The low alarm right now, it says it is okay because, you know, obviously the metric is way above the threshold that we set of 20. But then the high alarm, it has gone into the alarm state, right? Which basically means that application auto scaling would have sprung into action and it should have launched additional. So we have 1 task, and now we have 5 consumer tasks, all right, and that you can see in the dashboard, and 5 of them are running. And if I go to this dashboard where I look at these metrics, and if I refresh it, and you'll have to wait a few minutes, you know, for it to see, you can see that this one that suddenly plummeted down, right?
Yeah.
Now that is the rate of messages produced. That is the computed metric based on which we are actually doing the scaling or the target tracking. And it was initially trending close to, excuse me, trending close to 100. After having launched 5 tasks, and you can see that it basically came down to 20, right? Which is the value that we specified in the configuration file. And if we wait for a few minutes, you know, you will see that the red line, which is the combined rate of messages produced by the consumers, in a couple of minutes, you know, this will actually trend up and catch up to the blue line at the top, which is the rate at which the messages are getting produced. And that's because we have now 5 consumer tasks, each of them consuming roughly 20 messages per second, and it kind of pulls abreast of the producer. So that is how, that is one way, rather, to perform application auto scaling of your ECS service using a custom metric.
This is fantastic, and it's something that I think is a really common ask. Is how do I scale, especially Kafka consumers? I mean, this is literally something that I hear asked for all the time. And so it's awesome to get this as an example. And we've done this using, or I should say, you've done this using ECS and using CloudWatch, that CloudWatch SDK, also showing it happening using the Prometheus metrics. But you could just as easily set something like this up in EKS and have this happening in EKS as well. So none of this is exclusive to one service or another. It's just logic that we're applying.
Right. Except the only the challenge always is it is easy to collect the metrics, like I mentioned earlier, that it's always the more challenging part is, okay, what is it that you do with the metric? When you set up these alarms and when an alarm is breached, right? In EKS, the Kubernetes has this built-in horizontal pod autoscaler, that is capable of scaling your services, and you can also funnel the CloudWatch metrics, into that horizontal pod autoscaler through what is called as a CloudWatch adapter, and then there are other ways to also to perform autoscaling in EKS. Whereas on ECS, this being an AWS proprietary service, we don't have a whole suite of tools, open source tools. We basically make use of application autoscaling, and this is how we make it scale based on a custom metric. And there it is. We have waited long enough to see the red line catch up to the blue line, and of course, if I were to just to kind of round it up, I'm actually generating the load using a Kafka client that actually happens to be running as a Kubernetes deployment with 2 pods. And if I were to actually go and decrease the load on this thing, and for example, I can very quickly go and edit this deployment and set it to 1 replica. And by doing so, I basically now cut down the rate at which the messages are produced by half. Right? So if I go to pods, it should actually start. Well, anyway, I thought it should.
Yeah.
Scale down
and
scale down. Yeah, I think I changed the wrong one. Yeah.
If you scale down the producer, we would get probably half as many messages coming through, and then over time, we would see the target tracking auto scaling notice and take away our consumers. Right. It looks like based on the setup that it would take probably 15 minutes. Yeah. So again, we want
don't
that
have
to be
time.
Yeah, we don't, but we want that. That's good though. We want that to be conservative. So if you set this up on your own out there, definitely test that out as well. Go get a cup of coffee and come back, and you'll see it in the graph that that it's scaled out, that it's scaled down. So that's really cool to see. VG, this was awesome. I really appreciate you putting all this together. And where can we find? Actually, I think I have the blog up. Let me find it.
Yeah, the blog. So the blog has the custom code that I wrote for this is the Go program as a lambda function for computing that metric. The entirety of I know that because that was just like a 1-page program. The whole the Golang code is there embedded in the blog, so there's no separate Git repository or anything like that. And then the rest of it is all. I mean, I do provide information about how to set up the CLI, AWS CLI commands for setting up autoscaling with application autoscaling. And those are also provided in the blog post. So if anyone is interested in trying it, you have all the information available in the blog. You're most welcome to reach out to me, Brent, or any one of us. If you're interested in trying this out, and if you have any questions.
Awesome. Well, thank you for joining us, and I hope to catch you again on the next episode coming up next week. And until then, tweet at us any ideas, anything you want us to talk about, and we're open. So so let us know what you like and what you want to hear about. And thanks again, VG, and I'll see you around.
Cool. Bye-bye. Thanks.